All right, well, let's go ahead and get started. Good afternoon, everybody, depending on where you are in the country. I'm Greg Shorten. I'm the Chief Client Officer at Aspirion. It's my pleasure to welcome you to today's event regarding data science and healthcare. We're fortunate to have the CEOs of Aspirion and Qventus leading our discussion today. Jason Erdell is a CEO at Aspirion, and prior to joining Aspirion, spent 15 years in private equity-backed healthcare organizations within their executive leadership teams. These companies included Press Ganey, Change Healthcare, MedAssets, and the Broadlane Group. And throughout that time in his career, Jason's really been focused on scaling and modernizing U.S. healthcare through organic and inorganic growth, and with significant development in business intelligence, robotic process automation, machine learning, and artificial intelligence. Mudith Garg is a CEO and co-founder of Qventus. And as you'll learn, the Qventus platform uses machine learning and behavioral science to automate patient flow and transform operations for leading health systems across the country, including academic, community, and safety net hospitals. Prior to Qventus, Mudith co-founded multiple technology companies, including Vidopia and Hive. He also spent time in McKinsey and Company's healthcare practice, helping large providers with organizational transformation and performance improvement. He's been recognized for leadership as one of the Silicon Valley Business Journal's 40 Under 40, and he's a Stanford StartX mentor. So throughout the presentation, if you have questions, please enter them in the Q&A box at the bottom of the screen, and we'll get to as many of those as we can at the tail end of the session. Additionally, we will be providing the presentation to all attendees as a follow-up to our session today, along with responses to any questions that we are not able to get to within the time that we've got here today. So with that, I want to thank everybody for joining us and introduce Jason Erdell, CEO of Aspirion.
Great. Thanks, Greg. Really appreciate it. Couple of things to start off before I start going into some of the slides that we had. First, it's great to see the interest in the topics. I think they're very relevant. We'll talk about what we're seeing in the application of these topics in a couple different ways. I'll say the U.S. acute healthcare market is $1 trillion. We've got about a third of that represented on today's call. So again, I think a clear indication of the interest and probably just recognition of the importance of some of these data science topics. So I appreciate you guys carving some time out of your busy days to have a conversation with us. I'll be starting out with, I'll call it maybe the introductory course, a 101 on some of the data science topics, and then some of our applications that we've seen at Aspirion. And then I'm going to pass it over to Mudith, who is really kind of the graduate level. Of course, I think when I first met Mudith, he was a two-person company here in Silicon Valley. I thought I gave him credit for 3, but I understand the one person was just hanging out with those guys. But tremendous amount of experience. He's been doing this with Qventus for over 9 years. In fact, when I first met Mudith, the company's name was Analytics MD and not Qventus. When he ultimately changed the name to Qventus, or he and the team did that, I asked him why, although it sounded like a great name, I asked him why they did that. And part of the rationale, if not all of the rationale, was the fact that when somebody saw Analytics MD, they immediately went to the CIO and said, you should talk to these folks. And the reality of it is that this is not a CIO topic. It's partially a CIO topic, but it's really pertains to all of us. The pervasiveness that we'll see with some of these data science things, some of the examples that we give, I think resistance is futile at this point. These technologies are emerging, and it's important for us to all understand these. One thing I want to point out as well before I go into any of the prepared slides as well is this is not an advertisement for Aspirion. This is not an advertisement for Qventus. The goal of today is around education. Our firm belief is the more educated that we are as a healthcare community, the more capable we'll be at actually bringing these technologies into healthcare and having the positive impacts that we absolutely know they will have. Last thing to mention before I go in as well is, whereas both Mudith and I are both located in Silicon Valley, this is not a Silicon Valley thing anymore. It's everywhere. It will be everywhere. And the emergence, just the applications of these technologies and the pervasiveness is really exciting and maybe a little bit alarming at the same time. So we all need to be prepared for them. This is, again, not an advertisement. I just need to give you some context as to who we are. Aspirion is focused on revenue cycle. Moodith's business is very different in its application, although we all share the common thread that we're here to support the healthcare provider community, notably large hospital systems and other hospitals. I sometimes say that we focus on curveballs within revenue cycle management. It's all in reimbursement. We don't do any patient collections, but we stand at the plate, we watch the pitcher, and if the curveball comes in, we swing, and we think we do a pretty good job. If it's a strike down the center of the plate, that's not us. The reason why I mention this is that maybe some more mainstream revenue cycle, the application of some of these concepts are probably easier, although still not as widely deployed as we suspect they soon will be. But in our corner of revenue cycle, again, this is the most complex stuff. 5 or 8 years ago, people would never have considered probably deploying some of these technologies the way that we're doing today, simply because they're such unique in corner cases. So it just speaks to the pervasiveness of the application of these technologies. We have a lot of large clients. About 1 out of every 3 in the U.S. is a client of the top 100 of Aspirion. So we have a lot of experience. A lot of you are represented here today. We appreciate that, and looking forward to having a great session. So into the real content that you guys hopefully are a little bit more interested in. First off, when folks talk about a journey, particularly around data science, or even more specifically around one of the technologies that we'll talk within data science, you'll commonly get the question, or I'll commonly get the question, like, where do we start? This is clear. It doesn't matter what you're doing. It's really around structuring your data. And we ourselves had to do that quite significantly in order to start producing some of these algorithms and some of these analytics that we do. What we mean by that is we're really looking for data. We're not looking for information. We want to make sure that that data has meaning. So we have metadata to understand what is the data that I'm looking at. We want to use consistent data taxonomy. So that we're able to more widely deploy some of this intelligence. And you really don't want to manipulate the data. The more raw it is, the better, so that there won't be any misinterpretations as to how that would happen. This is, I'm making this sound trivial. It's actually very complex. It probably took us close to 2 years to do with the data sets that we had. And so you guys are probably on different degrees on this journey, but extraordinarily important to have well-structured data. So one thing I really want to focus on here is there are 4 technologies that constantly get conflated with one another. And one interesting aspect I'll bring up, Moodith and I even had an interesting conversation as to one of these. I'll point it out when we get in there. Sometimes and you'll see the data layer that's underneath all of this. Sometimes we'll refer to thinking like a human and acting like a human. And I think this is just a spatial representation as to what these different technologies, where they most commonly reside. There are some corner cases. You can even see an overlap on there that I say is debatable. And I think it truly is in a modern definition of what artificial intelligence is. But I have these probably a little bit too tightly confined here, but I think for the most part, these are accurate. So you look at business intelligence. Business intelligence should not be confused for artificial intelligence. Business intelligence is really around surfacing data, surfacing patterns in historical data. I'll talk a little bit more about this on the next slide, but it's really, I'd sometimes refer to as looking in the rearview mirror and understanding maybe what just happened. Extraordinarily important, and is very important for us as we went on our data science journey. The broader concept in here of artificial intelligence spans a pretty wide area, and this is where Moodith and I had a debate even as to how we would represent this. I think and Moodith is correct, and I never want to argue with Moodith because he knows so much about these topics. But if you were to look at artificial intelligence 50 years ago, we might have been thinking about a calculator, or maybe 70 years ago, or what have you. We probably would not attribute a calculator as being a piece of artificial intelligence, although in the strictest definition, it more likely than not is. It's evolving over time. We talk about things like driverless cars. I think that's a common application where people refer to artificial intelligence. And you can see if in the analogy of a driverless car, I guess in the example of that, you can see that in order for that to be successful, it needs to both think like a human and act like a human. What that means is that it's also leveraging a portion of artificial intelligence, which is machine learning. And machine learning is really all about experiencing additional trials, observing data, and from that getting smarter, just as any human would in any of our own development. And then finally, on robotic process automation, that is really, I would say, a more prescriptive version of that. There are algorithms that are deterministic that tell things exactly how to operate. These might look like a bunch of nested if-then statements, for example, but it doesn't have, robotic process automation by definition does not get smarter over time. And I would argue that its application of something that looked like artificial intelligence is very, it's very narrow and on very tight rails, but that's why you kind of see a little bit of an overlap there. So I'll go into just a little bit more. What's important to make sure that we're making these distinctions so that when I talk about it, and then more importantly, when Mudit talks a little bit more about it, that you understand the terms that we're using. So if we take a look at these four technologies, what I want to do is really talk about some common applications that we would use, and then also talk about common misuses, because it is not uncommon to misuse some of these technologies, although well-intended. One notable thing when you first look at this, you'll notice that I don't have a lot of common misuses on machine learning and artificial intelligence. They probably do exist, but in reality, because these are more nascent technologies, they haven't had as much opportunity to be misused. I think you could probably think about those. It's really more about getting them to the common applications. But let me talk a little bit about each of these. Business intelligence, again, and I don't want to reiterate what I've already said, but you're really looking at surfacing patterns in data, perhaps metric management. We all look at metrics and see how those operate. Some of the common applications you will see. We use Microsoft Power BI, which is a great tool. You'll see things like Tableau, which was recently purchased by Salesforce, and then ClickView. Those are probably three of the larger applications, but there are many, many others besides those. They're great at researching hypotheses. I think our revenue is dropping because of this, or I think we're having patient leakage because of that. And going through and being able to look at the data and see if your hypotheses are confirmed with the data that you're actually recording. So those would be some really good common applications of business intelligence. A misuse, I would argue, and by the way, I will, in a mea culpa, say that we have been guilty of this before ourselves, would be to create canned reporting out of business intelligence. Business intelligence is really about interacting with the data. You'll hear sometimes OLAP functionality, which allows you to kind of cut and dice data. You can move date ranges, you can select certain facilities and so on and so forth. If you're going to do canned reporting, you probably just want to do canned reporting. If it's going to be deterministic, if it's going to be stagnant, I would typically avoid using BI for that, because it's just overcomplicating something that is relatively straightforward. In robotic process automation, I think the best use, I will say, is really automating that. Well, it says it right there, automating someone else's code when they won't modify it for you. Many of you are Epic users, right? That's a great example. If you have recursive tasks recurring in Epic, feel free to send in a request to Madison to see if they'll actually change the code, but there's a good chance they won't. In that case, you can actually use RPA, and sometimes people refer to the bots, to actually do recursive tasks when you have an unwilling technology partner. This would also apply if you're working with payers, for example. It's unlikely that the payer is going to try to facilitate the reimbursement of care when they have other high priorities on their list. I will say the misuses I see more than anything else is when you do have a willing party, to use RPA instead of using just traditional data ingress or egress. If you need a data file, request the data file. Don't try to create a bot that will go out to some website and pull the data that you should just be sharing. And if it's your own code, if you have a proprietary system, RPA is not a great use for that. You should just simply modify your code so that it does what you want it to do, versus having a bot try to streamline it. And then, I won't go too far on this because I want to go through a couple examples, and I want Mudit to really be able to talk about some of the AI applications they've done. But machine learning, it's also surfacing patterns in data, but I think the difference between that and regular business intelligence is I sometimes would think of it as looking through the windshield as opposed to the rear view mirror. Machine learning can actually take a look and assign meaning to patterns within data and therefore predict what future data will look like. And that can be very helpful. A very common application for that would be forecasting, right? If you see this many patients coming in now, and I'll use an example where we utilize it for forecasting. How many patients might you see tomorrow or the day after? And what are the things that are impacting that? What are the meaningful variables that might be impacting that? And then finally, with artificial intelligence, although there's a lot to this, I'd say that sometimes if there's a human task that's perilous, right? I saw that movie a while back, Chernobyl. Those are examples to where it would be great if we had technology that could actually go into a hazardous situation and make it safer. You could even see some examples maybe with things like Intuitive Surgical and Neptune robots, right, where it might actually be behaving like a human and maybe more precisely than we could as humans. So those would be a couple good examples there. So I'm gonna walk you through 3 applications we had really quickly to kind of reinforce the first 3. And then I'll move over to Mudith, who's had some more advanced applications of AI that I think you guys might be interested in. And some key learnings, by the way, along the way. So BI, here's a good example that you guys, I think it hopefully will resonate with you. The situation is as a provider, I should say as a partner to hospital systems, we, and one of our service lines being motor vehicle accidents, we knew that COVID was having material impacts on our own motor vehicle business, but also on yours as well, because this is a meaningful source of revenue for you. And as great as we probably cherish the fact that people were getting less automobile accidents, nevertheless, we all had the plan for this. What we did is we took a look at inbound claims and volumes of inbound claims, identified when impacts were likely to impair our own financials. And then we made decisions, like, should we be hiring as many employees as we needed to? Where should we deploy our resources? Should we redeploy our resources? We've been growing very quickly, so we've have new clients. We're very fortunate to have new clients. But when the motor vehicle accidents slowed down, that impacted our volume of workload as well. One interesting fact here, I'll do this on each of the examples I have. We knew traffic was down 70% before it was published. I literally had the data, and we had enough market share in the US that I could see our inbound claims were down 70%. And about 2 months later, I saw a statistic, I think from I don't know exactly, it was some government agency, and they identified that motor vehicle traffic was down 70%, which of course we already knew. So that was an interesting takeaway. But again, I think the takeaway here is that BI can surface emerging trends and help you estimate kind of future impacts. And there are all kinds of use cases on this, but this was just one that we utilized ourselves. Let me give you a machine learning example that we're doing right now. And this is really around forecasting cash collections for our clients. And also for prospective clients, when we say, how much of an impact can we have by partnering with us? If we have certain elements of data and we can see patterns in that data, we can predict how long we think it's going to take for the reimbursements to come in and at what magnitude they'll come in. So we monitor things that we refer to as success and liquidity rates, what percentage of claims on a certain service line will actually pay, and at what volume of gross charges will they pay. When machine learning looks at these, it will start to recognize, it'll say, I've seen a claim like this before. In fact, I've seen 1,000 of them that look just like this. And this is how they ultimately got resolved. That's a very powerful thing. And the larger the N we have, the more occurrences we have, the smarter the algorithm gets over time. And it can predict with very accurate specificity exactly how much revenue we can collect and how long it will take for those collections to come in. One interesting fact here is we found over 30 independent variables, and growing, by the way, that may factor into cash forecasting. So these are things that, before it was just, okay, when it comes, and hopefully we can find as much as we can for you. But now we're far more capable, and as we continue to invest in these algorithms, far more capable of identifying a revenue forecast in this case, but again, could have a lot of other applications. So again, the key behind machine learning is utilizing historical experience to predict future experience and to recognize things. There's a whole level of detail that goes below ML, and there's a ton of really good content out there on the web if you want to get further in this, or if we end up doing another session. But it's a real fascinating area within artificial intelligence. And then finally, I talked about RPA. With robotic process automation, what we're utilizing is we're actually sweeping payer sites for claim status updates. And so what that means is we can't go to a payer and say, hey, why don't you tell us exactly when you changed the status of a claim? You'll get information coming back. You might get an 835, but really knowing where it is in their process. Historically, how we do this is we go into websites and we take a look and manually enter this recursive pattern of data to actually get the information back that we needed. Now what we're doing is we're starting to deploy, and we've actually have some really good examples of doing this, bots that will go out and perform those recursive tasks, and will actually grab the data that we need, the claim status, and get it back to us very quickly. The great thing about this, and this fun fact that we added here, is we'll know almost invariably when there's been a claim status change within 24 hours of it happening. Utilizing people to go through and constantly check this, it's just not pragmatic to do that every night. And so for us, when we take a look at it, and we look at the deployment of any of these technologies, our goal is to always get more collections for our clients, because that's why they've hired us. But you each have your own missions, and obviously these technologies can help in a very wide array of situations. So what I'm going to do right now is I'm going to turn this over to Mudith, who will actually talk about, I think, we'll talk about some of the other applications of these technologies, and we'll talk about some even more advanced applications that I think you guys will find intriguing. So with that, I will pass it over to you, Mudith, and I will advance your slides for you. If you need to, if I'm not going fast enough, you just let me know.
Will do. Thank you, Jason. And thank you everyone for joining. Appreciate the opportunity. That was a great overview of data science and AI. So what I was thinking I'll do is build on what Jason was sharing, and perhaps share some of the key lessons. As Jason shared, I've spent the last decade applying AI, machine learning, and such technologies to healthcare operations. And I'll do that in form of sort of just sharing some of the battle scars and some of the learnings and lessons we had along the way, and how that shaped how we think about applying AI and machine learning into the healthcare environment. So maybe to start with, let me just give you a bit of a backdrop and overview of who we are. We work with health systems to empower real-time operations. We today do about 15 billion plus predictions to inform some of the most critical operational decisions they have. And this was actually quite important, especially with the pandemic and the focus on hospital capacity last year. The way we do that is through a combination of AI and machine learning at the core, but on top of that, behavior science and expertise to make sure we can repeatedly and reliably deliver results for our customers. We have about 120 plus deployments across a huge variety of health systems. I think, as Jason was saying, this isn't a Silicon Valley or a academic or highly academic environment thing. We have safety net hospitals, we have community hospitals, rural hospitals, and big academic hospitals. And we've seen this be able to be applicable across all of that. So that's a bit of a context of who we are, maybe a little bit of how did we get here. I'll maybe start by sharing sort of what brought me to this problem in the first place, and we'll go from there. So probably about 12, 13 years ago, when I was a part of McKinsey & Company, we were working with a rural hospital, and it was really eye-opening for me the first time I did work with a rural hospital. And there are things that I saw that were amazing and very remarkable. But I also observed a pretty interesting dichotomy, right? Like, even this rural hospital had world-class clinicians and world-class treatments and world-class equipment and therapies. Yet, I think all of us would know that the experience of the average patient tends to be far from world-class, right? So if you want rarest of rare diseases treated, we have a lot of that available in the healthcare system. Yet for the majority of the patients, it falls far short. And it was happening in spite of heroic efforts, cheerleading from everyone involved, what people would do whatever it took to take care of patients. And sometimes there'll be someone, a manager who really focused in on a problem, stepped back, did an improvement effort, things would get better. But there were just hundreds of similar things that required their attention. And as soon as their attention moved to something different, it would sort of fall apart. And that sort of was my realization that we are wasting the potential of all these world-class clinicians, equipment, therapies, and world-class healthcare itself would be impossible without world-class operations. So that was kind of the thesis first. And I would confess that biased as an engineer, my mind went straight to data. Like, what can data do to build a reliable system so we can have the right things be easy to do and happening all the time. So that's what I set out to solve. And actually, the first vision of the business was not too dissimilar. If you go to the next slide, Jason, not too dissimilar from what's laid out here in a letter from Jeff Bezos to his shareholders. When I first started, I thought about the fact that, look, we have been spending 10, 15, 20 years entering data into systems in healthcare, right? And actually, it's in a pretty expensive way, i.e., on the backs of our care teams. And it really hasn't come back to help us yet. So there's got to be a way that we can use that to come back to help us. I had already seen that there was a lot of appetite for dashboards, but just as Jason was saying, when things got busy, looking backwards was not as important for people as to look ahead and to figure out what they should do. So it made perfect sense to look towards AI and to think about what we can do. And as I was sharing in this letter, I mean, it was already a letter from 2017. Jeff Bezos shared something similar that he said, look, big trends are not hard to spot, but they can be strangely hard for large organizations. And one of the trends he talked about was ML and AI. But I think one of the other important points he said is that machine learning and AI in his sort of understanding of his own business would transform almost every aspect of the business that they ran. And it wouldn't be that visible. It wouldn't be the visible aspect. Like some of the aspects are visible, like Alexa and what it talks to us. That's a visible aspect. But the thousands of decisions on what product is going to be in demand, where do I place that product, which warehouse should have inventory, and in that way, almost delivering eventually a magical experience where they can deliver consistently in 2 days a package to us, but because of all this underlying intelligence that is underneath all of this stuff. So we started with that as a core thesis. We started with applying and building machine learning algorithms in a variety of settings. And actually, the first one we did about 10, 11 years ago, if you go to the next one, was actually in a maternity environment, right? We started applying machine learning. My background, one of my co-founders' backgrounds from Stanford was in that area. So we started applying it, and it made perfect sense because healthcare is actually even more so than the environment Jeff Bezos was referring to, which is delivery of packages, which is much more reliable, much more like-sized. Healthcare is way more complex, unpredictable demand. Each patient's progression is variable. It's a highly people-driven business. So the fact that machine learning can learn and adapt itself will give an even more applicability in an environment which requires a lot of adaptation because things are always changing in our environment. But we also learned that the data in healthcare is quite challenging, right? It's very hard to extract real-time data. Data quality is actually challenging, largely because it's mostly human-generated data. It's on the backs of people entering it. So sometimes it gets entered incorrectly. Sometimes it doesn't get entered on time. And all of these things matter to an algorithm, right? So for example, what the quality of data looks like retrospectively is very often different from what the quality of data in healthcare looks like in real time. And if a model runs and gets the bad quality data, it actually doesn't perform as well. So we have to build a ton of our core underlying platform to be able to run in real time, detect drifts of data quality, and be able to be strong and resistant against those issues that often plague. So the first thing, similar to what Jason was saying, is be very, very mindful and understanding of your data, of how it represents, and how it can, how much it can affect everything that we do downstream from that in terms of AI and machine learning. The second experience was actually quite interesting as well. Like, so as I described, the first place we were predicting was actually predicting in a mother-baby unit how many babies would be born so that they could staff accordingly, right? So I would spare you all the details of some of the fun anecdotes of that the staff believed in, like a low-pressure environment would cause a baby to just come out. So we pulled in weather data into predicting babies, and in the ED, similarly, some anecdotes of how there was a strong belief that full moon nights are going to be significantly busier in the ED. Turns out neither of those two are true, by the way, if anyone's still curious about those things. But it was a really fun time to try and build these sort of tribal beliefs into the model and see if it pans out in the data or not. And as we did all that, we found we could actually predict quite well. So we used to predict and give our predictions every morning to the nurse manager of the unit in the mother baby unit. She'd look at it, I'd ask her for feedback. And especially I remember one of these days really well when I knew we had done very well. I knew we had predicted quite well. So I went to her and asked, like, hey, how were our predictions today? And she said, they were fine. I was like, what do you mean they were fine? Like, they were spot on. Like, what more did you want? She's like, yeah, I only had 2 minutes before the shift huddle. I like thought about it, but I just didn't have time to think about what it was right, what if it was wrong. And I didn't have a chance to do anything about it. I was like, that is such a shame. Like, for all this intelligence we gave you that could have prevented you from being short-staffed, nothing changed. And that was our first realization that predicting alone is not enough, right? If you think about building reliability into the system, reliability needs to come from having high confidence that the same and the right thing will happen again and again and again and again. So we need to not only go from data to an insight to a prediction, but actually to an action, and more importantly, from an action to a habit. And that became a very, very core lesson. And we used a lot of core behavior science theory to design the platform to have these capabilities. So what's shown here is the behavior science theory's 3 core principles of forming a habit: a cue, a routine, and a reward, right? So if I need to build a habit to go to the gym, something should give me the cue to remember to get up in the morning, and maybe that's my alarm clock, right? I need to make and have a routine that makes it super easy to do it. Maybe my bag's packed the night before and I have my gym set up and like I know what to do and like I know exactly when to go. And so I don't have a lot of thinking involved. And then lastly, some degree of accountability, some degree of reward coming back, make sure that that sustains itself and becomes a closed loop. So we actually built that as a platform. So we go to the next slide, Jason. We went back to the drawing board and we sort of understood that we had to incorporate not just the AI, but all of these components to make sure that we can consistently go from data to habits. So the AI helps us with identifying issues before they happen, but then we have to make the right thing to do, the easy thing to do by orchestrating the actions. And then we have to have this feedback loop through managing of accountability so these processes don't decline over time, right? So those 3 things were quite core. And this was a really, really fun time. So we were able to, once we built these core capabilities, we could rapidly enable brand new use cases for health systems on a call, right? I remember like talking to a health system that was worried about patients readmitting through the ED, but not having their care coordination team involved early enough. And here they said, is it possible when a patient walks into the ED, if they've been here recently and you have a high degree of confidence they're going to get admitted again, you could tell our care coordination team right away. We did that in a half an hour, right? Like we were able to enable that kind of a use case within a half an hour and enable this new workflow that they have. So that was the power of these capabilities. That was just amazing and limitless. And we started seeing people's strong desire to apply this to many, many, many different areas in the hospital across the board. And that as we start sort of going deeper and deeper in new areas, we learned actually another lesson, which is the right solution to solving this required a more complete system than even the technology, right? The capabilities, if you go to the next slide, Jason, were very core to solving a problem. But for most health systems, when they wanted to solve a business objective, we didn't just need these new capabilities, but what's the right management practice to go with it? What's the right workflow to go with it? What's the right hand-holding that we need to have for staff? All of that had to be in place. And we realized that instead of sort of the experimental way of going and trying AI and machine learning, given the complexity of issues, given the complexity of data, given the changing of workflows, we found tremendously more success in going and saying, we're going to be extremely prescriptive in our point of view. And we're going to pick a problem at a time and have a very prescriptive playbook on exactly how to do it. And this is very, very important because I talked about some of the complexity of data. I talked about some of the complexities of the machine learning itself, but it's actually a very intricate design to make machine learning successful in that you have to think about how well is something being predicted and therefore what's the right workflow. So if I'm predicting something with a high degree of certainty, maybe I shouldn't even bother a human to check with it and actually should just go straight and do the action. Or if I'm pretty high degree of certainty, but my downside is high of taking this action without oversight, I should have oversight. Flip side, if it's a problem where, you know what, it doesn't matter, it's a heads up that the ED is running out of capacity and I would rather know than not know. And maybe then the right workflow is to give a heads up more often than not. So you can see how based on the model, the workflow is different, based on the situation and the problem, the cost of being wrong and the cost of being right, the right workflow is different. And so it requires an intricate design of all the aspects of this whole solution in one go. And I think that's a very, very core lesson that we learned and has really, really helped us be able to repeatedly and reliably drive results in our customer base. And we took the same approach and actually built a set of COVID-19 solutions last year that also stood us in good stead, because within 8 or 9 days, we had to build a full system to be able to help health systems manage capacity all the way. And we went all the way from supporting the White House and states and such in understanding hospital capacity to how many negative airflow isolation rooms will I have tomorrow to take care of patients at a single hospital level, right? So that required this complete system. And I think that's a really critical lesson that we learned as well. So we've actually now applied that to multiple different areas. So it's not just in one area. We've applied that in one of the core problems that we see health systems want to apply. That is a problem that has been pretty long-standing and one that is had been tough to solve sustainably, which is patients spending excess time in the hospital. And it's one of these magical problems where the patient's incentive and the health system's incentive, regardless of fee-for-service or fee-for-value, is the same. I don't want to be, as a patient, be in the hospital an extra day. The hospital doesn't want to pay for that extra day out of their own pocket. Yet it given the complexity of what happens to a patient, keeps happening. So that's one problem area we found a ton of success in applying that to. A completely different problem that has been really topical and top of mind is, how do I manage my surgical capacity and drive surgical growth in an environment that this is a pretty expensive asset to maintain? Or stay ahead of variations of demand in an emergency department. I think that is traditionally often thought of as an unpredictable area. COVID-19, how do we take something that has never happened before and be as well prepared as we can be ahead of any surge coming in? And then same problems that not only exist at a patient or a unit level actually exist at a system level. Many of you are consolidating and bringing many of the hospitals together. And in that environment, there's a strong desire to think about solving these problems, not only at a hospital level, but at a system level. And we actually have solutions that help health systems do that as well. And so we've seen in a pretty broad range of situations the applicability of this methodology of a complete system. So I'll give you one example of this. On the inpatient side, we had consistently seen that the way to reduce excess days was having early and accurate discharge planning. So many people think about, like, I need to have a plan of when the patient will leave or where the patient will go. So I can plan the sniff. I can plan that their MRI should get done. I can plan their post-acute visit. I can see if there's something that stands in their way. And typically speaking, care teams have a good plan by the time the patient's leaving, but that it's not that helpful at that point in time. It's really important to have that plan in the first day or 2 days, because that's when you can actually solve these problems. So we built some really complex AI, which actually went beyond machine learning into these probabilistic inference models, which looks at every individual patient. This patient has liquid diet, and now they are on solid diet, and they have IV medications, and uses all that to be about 3x better than a care team in predicting when a patient will leave the hospital and where they might go and what might stand in the way. And this actually makes sure that a much higher degree of patients have an early plan, have an accurate plan. And then to go above and beyond, the machine learning highlights another identification of issues of, like, hey, the MRI might stand in the way of this plan, or the physical therapy will stand in the way of this plan. So this is the identification of the problems and identification of the issues, but then we help orchestrate those. So if, yes, the team agrees that MRI is pretty important to prioritize, or in this example shown here, physical therapy is pretty important to prioritize, our system is escalating that and reaching out automatically to the physical therapy teams to make sure that is happening and following up and making sure that is consistently being tracked. And then from an accountability standpoint, a leadership standpoint, we track all of these things happening all the time to step back and say, here's the issues that are happening consistently across the hospital. our insurance authorization is always getting delayed for these types of patients. That is always delaying the discharge and the post-acute placement. And this is a consistent problem. This unit does a phenomenal job of this process. Please go and give them a congratulations. Or this unit needs some coaching, right? So that kind of leadership insight to close the loop on this. And we've seen when we do these three things consistently and repeatedly, we are able to reduce excess days. For the patients which follow this loop, we reduce them about 91%. And all as a whole in a hospital, we see we are able to cut that down by almost 0.5 to 0.6 days on a consistent basis. Go to the next slide, Jason. We've actually seen, last year there's about 70 years worth of excess time in the hospital that was eliminated through this process. And it led to 50 to 90 basis point improvements in cash flow margins, the $10 million+ of cost opportunity as a hospital. And most importantly, it takes all these fires that happen downstream and solves them upstream. And I think that is the real amazing part of having this AI trigger an issue and orchestrate the action and create that accountability, that you start feeling like the day is smoother and the day is calmer and things are happening much, much more smoothly. And I believe this sort of same type of consistency of results, this same type of methodology can be applied if you build this complete solution to many, many areas of delivery of healthcare. And I think almost anything that is process driven, and candidly, most areas of delivery of healthcare are process driven. So that's a bit of the lessons of both how important AI is, but also not to just rely on the AI alone, and make sure that you're building that habit loop on top of it and having a really prescriptive point of view on how to drive that. Great. I'll turn things back to Jason now. That was sort of hopefully some of the lessons that were helpful.
Yeah, thanks, Mudit. No, I think extraordinarily helpful, and it's interesting as you actually were commenting on that. I was reflecting on some areas, and when I first asked, I connected with Mudit. Besides just knowing him and knowing that they were doing stuff that was, obviously ML and AI related, my initial thought was, gee, that's great. It'll be really cool to be able to demonstrate somebody a group that's been doing this for 8 or 9 years. As I mentioned, with this Spearman, we've been doing this just for a couple of years now. Not many of the folks in our space have really been doing this, but as you were articulating stuff, Mudit, I couldn't help but reflect and say, hey, some of the things you're describing actually have impact within the revenue cycle as well. And I know we've got a lot of revenue cycle and financially focused folks on here, which I'm sure they love to hear the stories of the actual clinical delivery and things like that. But I was reflecting on it when you were talking, and I thought, wow, some of the things that you were doing there would actually impact ultimately the reimbursements, and a lot of it, like the 70 years of excess stay and things like that. Can you maybe just talk a little bit? And by the way, what we want to do is just, I wanted to have a few reflection points here, a little bit more conversational, so the folks could experience it. If we do have questions coming in, we'll try to include those as well. But what is your reflection, Mudit? Where would this fit within revenue cycle as you know it? Any thoughts there?
Yeah, I mean, I think you're right. Revenue cycle in many ways is another side of the same coin, right? As and when the delivery of care is happening, there are aspects of revenue cycle that you're trying to shape at that point in time through CDI efforts and through other efforts like that. And then with what's happened, you're also reflecting that care delivery back in what you're charging or trying to get paid for. And I think the same heroics, the same cheerleading exists in revenue cycle as well. People are trying to identify issues, people are trying to orchestrate actions, people are trying to drive accountability, but it's done highly manually, right? I mean, CDI is a good example. I was just talking about that, right? It's done today manually by a separate team that is scouring through the records and saying, hey, I see an opportunity here. And then going back after the care team's already made a care decision, at that point, a day or two later, going back to the care team and saying, hey, are you sure that patient wasn't malnourished? This looks like that patient was malnourished. Is that the case? If that's the case, is it just not documented, or are we not treating, or what's happening? And that's a broken way of doing that same process, because we are having somebody trying to do that after the fact. I think that same exact piece applies here as well, right?
Yeah, no, because I look at it and I say, depending upon decisions and data captured earlier on in the process, that ultimately will result in a denial. And we know once we get a denial, then not only is the denial an issue from a recovery standpoint, but also how many if I'd love to pull the group out here. I should have had a polling question on here. You might not know the answer to this, but how many clinical review nurses do we have that are reviewing what happened in the past to try to get a denial overturned? Could you imagine if we were able to deploy those nurses into care delivery and the immediate impact that would have? So yeah, it's pretty profound. I definitely see it in the denial space, but I think there are a lot of others as well.
I think that's a good point actually on the denial side. Like what if that was happening as the care was being delivered? Because every physician you talk to will tell you that they have so much more of the patient context while they're taking care of the patient. And if they miss something, they're much more able to confidently add that or change that or make sure it's reflected. But it's way harder 10 days later. It's way harder a month later. And so how much could we shape that by having that kind of intelligence in the moment?
Yeah, and roughly 3/4 of our denials are clinical in nature. Why did you not step somebody down from the ICU into a regular patient bed? Why did you not obtain a prior authorization? So yeah, I think that's pretty impactful. So Mudith, when you take a look, and you actually gave some good self-reflection out there, but you've also seen what systems have been doing as well, potentially on their own. What are some of the biggest mistakes when you see folks trying to do, and there's one that was really salient that you mentioned, so I don't want to steal too much of your thunder, but you already stole your own thunder by talking about the fact that you need the system around it, that the AI and ML is not enough. But maybe what are some of the other mistakes, and maybe they're related to that you'll commonly see as folks are well-intentioned but trying to deploy some of these technologies?
Yeah, I mean, I think as I was saying, the first and most important thing is to realize that it's not just that it's very important to match the prediction, the ability to predict, which is the data side of it, with the right workflow, and with a problem that's important enough that has enough ROI, right? All three of those things have to be true for it to be. So in many ways, it's not a machine learning or an AI problem alone. And you need to think through this much more carefully to do it. That's one piece of it. The second is, for many of these algorithms, even the machine learning side, it's not just the models. What looks great on paper, there's actually an article published in JAMA yesterday, which looked at one of the popular EMR algorithms that has been widely deployed. It was trained, it's a sepsis algorithm, and it was trained on standard data across all the billing codes of all their customers, and then deployed at each hospital. Actually, this is an example where machine learning can be powerful because each hospital doesn't document the same way. Each hospital doesn't have the workflows the same way. They don't do it at the same time. And therefore, the expected performance of that model was very different than the actual performance of that model. That seems okay. Okay, so what does that how does that matter? Well, it mattered quite a lot because in this case, it was giving an alert for a sepsis patient. And when that accuracy dropped, but the workflow was still to meaningfully go check up that patient when that alert is coming through. The workflow is designed on a high accuracy model, but it's not actually performing accurately. Now it's really doing the opposite. It's actually distracting. In that case, only 1 in 5 of those alerts was actually being helpful. Now, in 80% of the cases, then it's distracting the care team into going and doing a set of lactate studies and expensive work that doesn't need to be done. So I think that's why it's really important to have a full pipeline view of what's happening and have a system helping manage that. And it's something that is trained on your data, on your hospital, with knowledge of other pieces that are happening. So it's actually tuned for this use case, and you understand that it works or doesn't work. And I think far too often, people just take things at their face value and run that through and don't sort of appreciate till you've done it a few times that true enterprise system with the full ML pipeline, the ongoing management, the ongoing maintenance, the design of the workflow that goes along with deploying machine learning and AI.
Well, I'm gonna actually take this a slightly different place because there's a common data science. Actually, it's really around data analytics analysis. A lot of what we're doing in these things are really, you're looking at a dependent variable and you're trying to find independent variables that will predict what happened to the dependent variable, right? And so you're looking for correlation among certain attributes that then result in something else. And as you're talking about the sepsis example, that's what they were trying to do. The other piece that I think is actually quite astute that I don't think we officially mentioned yet, although you started getting there, was, okay, does it make sense, right? Does the result of what we're getting make sense? And there's this case study, I wish I had prepared it ahead of time, but you just made me think about it. This case study, it was this town in Germany that had a stork population that lived there during the summer. And then in the winter, they would migrate to Africa. And as they go down to Africa, I don't know if they bred there or bred in the other location, but it was this recursive loop of where, depending upon the season, they would come back to Germany. And so there were these data scientists who took a look at it and they said, okay, let's see the correlation between the storks and the number who arrived back at the migration and when babies are being born. And they actually did the analysis, and I don't want to geek out too much, but there's a thing called a p-value that describes the accuracy of it. And there's another thing called r-squared that describes the amount of variability. You looked at the data, the p-value was amazing. It was predicting very well exactly the baby population when it would occur. And it would also predict a very significant portion of the variability as well. So you thought you had the perfect algorithm here and that it was going to make perfect sense. And because it worked so well, of course, the conclusion that everybody came up to is that storks, in fact, bring babies, and that's where babies come from, right? So triangulating back on your mother-baby story earlier, it's just, I do think there's that element where you have to use judgment and say, is this appropriate? Do these results make sense? Do we have the right independent variables that are impacting the dependent variable? And a data scientist alone with not enough context of the environment in which it's being deployed could come to some very bad conclusions, to your point, and make some very bad recommendations. So anyway, that's good. Well, let me ask you this then. Let's go to the obvious question. Should hospital systems just hire a big data science team? Is that the approach here that works best? What's your opinion there?
Yeah, I mean, look, it's very critical to have leaders and the broader sort of staff in the health systems have a better and better understanding and appreciation of what data science can do, what it can do well, what it cannot do well. And I think from that standpoint, it's important to have some mix of that in there. But I think a lot of this learning comes from repetition and having reps under your belts. And just as you were saying, if a data scientist is looking at this problem only once and sort of, they wouldn't know the pitfalls, they wouldn't know where to look, they wouldn't know what to avoid. And I think that's why it's important to work with wherever, like, you need to have enough scale to do that well and to have enough repetitions. And I think we had this cycle probably 50 years ago when everyone tried to build EMRs and there were custom solutions that were easy, but then it became hard to maintain and became hard to scale. I think the bit of that is true here as well, where building an enterprise grade pipeline is hard, building a one-off is easy, building it once is easy, maintaining it is hard. And then certainly making sure you have enough reps to understand the pitfalls and when it's being deployed and what's working and what wouldn't work is much, much, much harder. So my answer is certainly biased a bit. But I think it's the right answer, which is, I think you need to have the understanding and depth of understanding to be able to ask the right questions. I think hiring data scientists for building would probably not be the right core strength for most of the health system partners we work with.
Yeah, I think it's getting that knowledge up. But the other thing I'll mention is, and just knowing this as we've hired our own data science team, a few things. One, data scientists are super expensive, right? So by the way, if any of you guys who have kids out there and they're trying to figure out a major, that's a pretty good one. They're also very fungible. They move. It's the average tenure I saw, just talking to some recruiters, and they said well under a year for a data scientist to be in a specific organization. So, those are some of the challenges that we saw as well. But I think your underlying point of you need, you can't, and I don't want to go too far down this path. There aren't a lot of data scientists out there that really understand hospital operations today or the delivery of care, because it's a pretty new science, right? And so even with our own team, we've had to spend a lot of time, I should say, to help them understand the context, so they don't make the conclusion that storks bring babies, right? And I think that was definitely a key learning for us, is that it requires that context. No one's going to come in the door. We're not going to find somebody who's just like an amazing data scientist that spent 20 years. If they're out there, let me know. But that has spent that in this setting. So I think we need enough empathy as business leaders and as hospital operators to understand the utility of data science. I think applying some of the learnings that you described too, Mudit, like you can't just put AI and ML out there and just let it do its thing. That's not going to happen. And then actually having the context of the setting of it. And the only way to do that, to your point, I think, is through repetition and being able to see this in a lot of different settings to where you start building that judgment over time. So I think I agree with you. It'll be tough for high end. It is self-serving because we both offer these services, but at the same time, I think it's going to be very difficult for hospital systems that are really focused on the delivery of care. They should be net consumers of AI and ML and not necessarily inventors of the code. Although, some of the larger systems might have the ability to do something like that. Okay, one last topic. We've got 3 minutes left. Question came in. So where do you see data science evolving within healthcare? Like if you have a crystal ball or a brain that can see around corners, are there any areas where you particularly look at it and say, boy, this is really right, beyond obviously the ones that we're already working on, or particularly that you've already worked on?
Yeah, I mean, I think I have always believed that we owe it to the clinicians and we owe it to the patients to have a system that can meet its promise, its social contract, right? Like when I say to you that I'll do this, I will do this. When when you send a bill, it's right. When you tell them that your MRI will be done, it gets done. Right? That's the when there's good experience and there's good trust, that's what happens. You do what you say you will do. I think there is a real shot at getting that kind of reliability in a healthcare system by using AI and machine learning in this way to build habits, to build reliability, to build automation. And I think that should be able to drive every activity of what we do. And today that's probably more machine augments a human or machine sort of suggests or influences a human. I think over time it takes more and more load off the plates of our people. And I think paradoxically, AI could actually help make healthcare more human by freeing up all of our clinicians and our people from these rote tasks and these easier to think of below their license activities, so they can actually work in the aspects of healthcare that are the most sort of pristine and pure of the human interaction, the personalization, and the interactions that we have. So I think that's what my belief is, and that's what my hope is of where this type of an application of data science can eventually take us. And I think it's not limited to any one area of delivery. I think anywhere there is complexity and a process and you have to do it, and there's different degrees of human judgment involved, I think over time we'll go through all of those processes step by step and hopefully have a role to play.
Yeah, I would offer machine learning, in my opinion, it thrives on uncertainty, assuming you get to the right variables, right? That's what it's really able to identify. Not too long ago, I was with the chief operating officer of Lucille Packard Children's Hospital, he's not here today, but I believe his organization is. And he was talking about as care goes outside the four walls of the hospital, which is a great thing because we can more efficiently deliver the care. There's also an opportunity to lose a lot of the data that's out there. That's why you see health information exchanges going up and things like that. I think being able to help in that interoperability across different care destinations will be a huge application of machine learning as well. I think about your example of potentially getting an MRI, right? And as those happen more and more outside of hospital settings, they actually get those organizations ready for the information that is knowable, but just not known at that point. So anyway, I'll pass it on. Greg, I will turn it over to you. I think that concludes our session, but I'll let you do it more formally than I just did.
No, that was great. Thank you, Jason. Thank you, Mudith. Really, really terrific session. And hopefully all of our attendees got a lot of benefit out of the time they spent here with us. We will be sending out to everybody the presentation and responses to any questions that we receive. I know sometimes questions come up after you've had a chance to think about the presentation and stew on it a little bit. In that event, we provided contact information for myself and for Mudith in the event that you want to reach out to us with further questions or just to follow up and continue and expand the discussion or invite others from your organization to do so. So I want to thank everybody again for joining us here today and appreciate you carving out some time to spend with us. Thanks, everybody.
Thanks, guys.